Okay, so in this follower type given as a roller follower, okay, and it is inline. For roller follower means inline radial type of consideration, that we'll see later when you draw the cam profile, because this follower type is not required when you take this what displacement diagram. It is not required. Next, lift is 25 mm, then base circle radius 20 mm, roller radius, that is new thing because roller will have the roller radius also, so 7.5 is given, and outstroke is URM and angle is 120 degree, and again there is a dwell of 60 degree, and return stroke with URM for 90 degree cam rotation, and then dwell for the remaining period. This is given in the question. Okay. Then you have to determine the maximum velocity and acceleration during outstroke and return stroke if the cam rotates at 1200 rpm in clockwise direction. Okay. So first you need to draw the displacement diagram. Okay. So you know that how to draw the displacement diagram. First on the y-axis you have to take the lift distance whatever is given. So lift is 25 mm. So 25 mm I will take vertical line on the y-axis part. So 25. Then 360 degree rotation what you are going to take, that will be on the x-axis. Okay. So if you take a scale of 2 degree equal to 1 mm, you will be getting around 18 centimeter line, right? So I will take 18 centimeter, that is 180 mm. So scale what I have taken is 2 degree equal to 1 mm. You can take your convenient scale, but preferably this will be better. So write your scale also, otherwise you will again ask what you have taken. Scale 2 degree equal to 1. So this I have taken. Okay. Next, which type of method you are going to draw? UARM. Okay, for outstroke, also for the return stroke, both are URM. Okay. So next I will just now divide the angle which is given. So first is 120 degree rotation. Okay. So from here I will take 120 degree rotation, and you have to divide into 6 equal parts. So that will be 20 mm. Okay. So I will take here and divide this into 6 equal parts. After that we have 60 degree dwell period. 60 degree dwell period means 30 mm, right? Are you doing along with me? Hello?
Yes, sir.
Then tell me. So next 120 degree of rotation of cam, how much distance I will take?
Sir, 10 mm.
Then no one is telling me. purposefully I am taking telling 20 mm. So I thought someone will ask, but you are not telling. I waited for some time. I thought you will tell me. Either you are not understood or you don't want to answer. Should tell, no? That's what I am waiting. So 120-degree rotation. So that is 120 will be nothing but 60 mm. Okay. So in your scale. So if you divide into 6 parts, you will get 10 each. No one is going. No one is telling only. Okay. What is your problem? I don't know. So I divided into 6 equal parts, first one. Next I will take this one 60-degree rotation, dwell period. So that dwell period is around 60-degree means it is 30 mm.
30 mm, sir.
Ah. Okay. Then 90-degree. So
45 mm.
90-degree means 45 mm. And Siva divided by 6 parts means how much will be the one distance? If you divide into 6 equal parts, how much will you get? One division.
7.5.
7.5. So you'll get like this. Okay. Next, I will divide this into 6 equal parts now. So here also at top side also I will to take. And one more thing, suppose if you are not able to take exact length, for example, if this is given 100-degree and 100-degree if you want to divide into 6 equal parts, how will you take? Anyone? Hello? Respond.
Divided by 6.
So 100 by 6,
We
how
will
will
do
you
four
get?
divisions.
How will you get it? It will be in point, no? If
Four
you.
divisions we can do now.
No, you can't take like that. You have to take 6 divisions only because that points will not get. So 6 divisions only if you want to get 100-degree, exactly it will not be possible because you will get in decimal. And if you take wrong in starting one decimal, last the division will be little bit more or little bit less. Okay. So in that case, what you have to do is that you know the line division method. If one line is there and if you want to divide into equal number of parts, you draw an angle downwards and then you draw equal distance on that line at any angle, and then you draw parallel lines to that to get the distance that you already learnt in school. So that division you have to use. Okay. Suppose here also 25 is there. 25 I have to divide it by 6. So how much I will get? If I divide this 25 by 6, how much I will get? One division will be of how much? 25 by 6.
4.1.
Huh?
4.17, sir.
4.17. Again see it is in decimal. Okay. So here also in that case you can you have to take the angle and then you can draw the parallel lines. Okay, I'll just show you that procedure also. Okay. So you can take any length here, any length, and from that length you can take the equal distance. Say you take around 11 mm. So from here I will take 11 mm line. I think 11 mm will be too short. I will take around 1 centimeter, 10 mm will take. Okay, 10. So you can take in the rounder. I am just taking like this. You can take in the rounder. I will divide this into 6 equal parts. I have taken. I will take around 5 mm. Okay, otherwise it will be very difficult. So I will divide this into 6 equal parts. So I already have the values. You do so you do accordingly. So from first one, I will take one line and then join this parallel lines to this first one to this last. You have to first draw to the last line, and then one by one you can draw parallel lines to this. Okay, so I have the values, so I will draw accordingly. Okay, so I'll be getting like this. Okay, so first you have to take one angle at any angle, then any distance, it should be same distance, then to the last point you join to the extreme end of this and then draw line parallel. Now you can see you will be getting equal distance. So now once if you take these lines, it will be equal. Okay, you can just check it out. Sometimes in urgency, if you don't have time, that time you can leave this, but when you have time, actually this is the exact procedure. You have to divide this, because if it is given like 25 mm and if the angle is given in 100 degrees, then 110 degrees, so directly don't divide into just take the dimension. That time you have to divide this. Even if here also, if the angle is given 100, you have to take one line here bottom, then you can take any distance, mark the points here and join to the parallel lines. Okay, so like that you need to draw. So now I will continue the URA method. So I will just draw a straight line so that I will get the construction line easier. So I am going to draw along with you only. So just go and start drawing this, continue it. So I will draw it line like this directly. So you can just mark the points. For my convenience, I have taken continuous lines here. Next, you know the procedure. So intersection of this, then from here, this intersection, then this intersection, then top side, this intersection and this intersection. Okay, then same way on the return part, join from the extreme end to this end, then later you can take this end intersection point, join over here, join over here, then same way this intersection point and then this intersection point. Then you start drawing the curve. I'll just zoom with this and again draw the curve. So from this one, this intersection, this intersection, then this intersection, and then this intersection. Okay, so this I will show you by different color so that you can find out. Okay, everything should be light. Okay, only this what I am showing by red color should be dark. Actually, this all are construction lines only, other things are construction line only. So for that you can see the lines, so I am drawing here that also dark, but whatever red color is then that should be there in your displacement diagram. Then same way I will take for the return part. You mark the naming also. I have not named 0, 1, 2, 3, 4, but you name it. Okay, so you'll be getting displacement diagram like this. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8 up to here 12 you will be getting. Okay, that you take. Then angle also here 120 degree and this is 90 degree. So and here also you can mark the points 1 dash, 2 dash, 3 dash and all. I am just worried about the construction, so you just mark the points. So for that it will be easy for you only. Okay, all I completed the displacement diagram. Tell yes or no. Hello? Hello?
Yes, sir.
Almost done.
Okay, so do along with me. Next I will draw the cam profile. So read the question what is given. In the question it is given that the base circle is 20 mm and the roller radius is 7.5. So this roller radius you have to take extra. And next what is the thing, cam rotation is in clockwise direction. So actually what is this use of this direction of the cam clockwise? So if cam is moving clockwise direction and when you use the follower direction and the cam direction, will it be same or opposite?
Opposite, sir.
So this condition will be helpful when you draw the cam profile. Clockwise direction means when the cam is moving in the clockwise direction, the follower will move in the anti-clockwise. So you have to mark the points in the anti-clockwise direction. What you have done in the previous thing, like this. So this is assumed that the cam rotation is in the clockwise direction. Means that's why you have taken the follower points in the anti-clockwise direction. So here also you will be taking same anti-clockwise direction of the points for the follower because cam is having the clockwise rotation. Okay, so now you will be drawing the cam profile with anti-clockwise direction of the follower. Okay, so first I will draw the base circle 20 mm radius. So at the center of the page I will take 20 mm radius.
Excuse me, sir.
Yes.
Sir, how to identify which you have to do, sir, like offset method or the other one?
Given in the
Profile.
question, no? Read the question. What I told in first line only I told. In line.
Okay. Hi. Yes. Yes.
What do you mean by inline? It is radial.
Yes,
Otherwise,
sir.
in the question, it will be given offset by some distance. Here, it is not specified, no? If offset is not specified, means it is assumed that it is inline only. So, read the question according to that, you will be getting. So, first, base circle. Are you able to see? Hello?
Yes, sir.
Yes, sir.
Respond. When I am telling you, you have to respond. So, next one, I have to consider the roller follower here. So, first I will draw the axis part for this. Okay. Next, roller is how much? 7.5 mm radius. Okay. So, what I have to do? I have to go from the top of this point and mark 7.5 mm, and then I have to draw one roller. Okay. So, first I will take distance, I will zoom it and show you. So, from this intersection I will move 7.5, that is the radius of the follower, and I will move above, and on this point I am going to draw the circle of 7.5. So, from here I will draw it. So, this will be exactly 7.5. Okay. So, this roller I will place on the top of this. Okay. So, I will be getting a roller like this. Okay. Now, what I will do for your convenience, I will draw one more circle through the center of this roller, that will be the radius of 20 plus 7.5. Okay, that is up to here. So, now I will draw a circle passing through the center of this roller. So, that automatically that will be 27.5. 27.5. So, that will be nothing but the prime circle. So, inside it will be the base circle, and when you take with the center of the roller, let us consider as a prime circle for this, and then from there we can get another circle. Okay. Then you do along with me, then only will be able to do it comfortably. Okay. Next, I will divide this into angles. So, how I have done in the knife edge follower, you know the angles. So, it is 0 degree, then it is 120 degree. So, I will divide this same way how you are done in the previous thing, because it is radial. So, I will take from the set this as the 0 degree. So, from here the center I will take first 120 degree. So, this is 120. Then after 120 the angle is 60 degree. 120 plus 60 is how much? 180. So, exactly the here vertical line. Then from here 90 degree. So, okay. So, I got this angle. I will show you the angle also. 120, 60, 90. Okay. Next I will divide this 120 degree into again 6 equal parts and 90 degree also into 6 equal parts. So each will be how much? 20 degree and then 15 degrees respectively. Same way 90 degree also I will divide into 6 equal parts. Angle will be 15 degree each. Okay. Are you doing along with me? Hello? Akash?
Yes, sir.
Akshay?
Yes, sir. Yes.
Shiraj?
Yes, sir.
Do along with me. Okay. Next. Now, in the knife edge, what you do, the tip, whatever you go getting exactly. So, but that will be exactly on that point only because it is having a knife edge. It will be sharp. But here, due to the roller, the procedure is little bit different. Okay. So, what you do next one? You have to take the distances what you are going to take in the displacement diagram, that is here 1 to 1 dash, 2 to 2 dash. Okay, here I have not labeled it, but you should label so you get the convenient points here. So mark the distances from 1 to 1 dash, 2 to 2 dash, 3 to 3 dash, 4 to 4 dash, 5 to 5 dash, 6 to 6 dash. So the maximum will be this distance, that is 25 mm. Okay, so mark these distances over here. Mark these distances over here. Okay, so here also I will take the length. Extend this line, then same way I will extend this line also. You take the exact distances. Okay. Okay, so you'll be getting the distances like this. Now what you have to do is that from this center this points whatever you got from there you have to draw the circles of 7.5 mm radius. Okay, so take the distance in the rounder of 7.5 mm radius, and then draw the circles on these points. Okay, then after getting this, you have to take a tangent to these circles and trace the points from this. Okay, so starting from this point, you take the tangent dot tangent to these circles. Okay, and complete the profile like this. I'll just take a color of this so that it will be clear for you. And the remaining arc also can make it dark. Okay, so we'll be getting a profile like this.